afternoon to all.
Good afternoon.
We have all gathered here for a case study discussion on smart irrigation system. So agriculture usually needs more water, and traditionally farmers used to water the plants manually without even monitoring the moisture of the soil. So that might waste water, and if over irrigation would waste the water as well as electricity, and under irrigation would make the crop yield very less. So we have to design a system such that we automate a system, and where human intervention is not required and the water is not wasted, we save energy. So I'll give you 5 to 10 minutes, discuss among yourself and design an embedded system which is automated to meet all these challenges. So hope you've completed your discussion. You can start providing the solution.
So, system overview. The solution we have came up with is a smart irrigation system using embedded systems. So we are all familiar with the embedded system because we are from DCE, our core department. So we use a soil moisture sensor and humidity sensors to sense the surrounding
Moisture content
moisture content and the humidity of the atmosphere. So using that we can tune the water pump accordingly. So it is a real-time monitoring system which the moisture sensor and the humidity sensor senses the environmental changes second by second. We can react to it accordingly.
So guys, since the system what we has given, talking about the hardware components which is used in this embedded system to overcome this problem statements, there are mainly 4 components we are using in it. Microcontroller, we are using ESP32 and the moisture sensor and relay module and the water pump. This is the 4 hardware modules we are using. So basically ESP832, it acts as the central processing unit which reads the sensor data, and it automates the relay module whether to turn on or turn off, and lastly it sends the data to the mobile app or the web dashboard via the Bluetooth or the Wi-Fi. So talking about the sensor, about the soil moisture sensor, it actually measures the sensor which is present in the it actually measures the moisture content present in the water. Then it automatically gives the signal through the analog signals to the microcontroller. So by noticing that whether this moisture is low or less, the microcontroller analyzes the analog signal and decides whether the water content is needed or not. So based on the instructions given, the relay module acts as on or off the water pump. So after receiving the on signal, the water pumps transforms the water to the crops and the field. So by using these components, it reduces the water wastage, and for correct time we can give the water to the crops, so we can maintain it better without needing the human intervention.
Okay, so coming to the system design and working principle. What we are going to do is, for the step 1, we are going to set a threshold value for the soil moisture sensor. So when we set it minimum threshold value, what we are going to measure is, we will measure the moisture content of the soil. So once it's it's less than the threshold value, the relay, it will send the signal to the relay and it will turn on the water pump. And then if the threshold value becomes equal, it will turn off. Same as if it will ensure that the water content is correct and there is no wastage of water and irrigation is done well. And once this is done, the farmer can also get the details in the application that we are going to design. In that, he can actually see when the pump, what is the soil moisture level and how long it takes, the weather conditions and everything, and it will help us to work with the irrigation system it makes the system optimal.
So is your threshold value based on the type of plant? Is it dependent on
Yes,
that?
it will vary according to the plants and crops. It mostly depends on the type of plant, as most plants differ in requirements of waters.
Next.
So by considering all the points in the case study, we can come up with multiple aspects like results and benefits. So the first one will be water conservation. So when we are watering the plants, there may be some wastages of water because of our carelessness. So that was water wastage is reduced, and the extra watering is also reduced in that water conservation. And the second one will be the labor cost. As it is completely automatic, so we need not worry about the work of a man in that way. So we can make it completely automatic. And the third one will be scalability. So in small scale industries and as well as in large scale industries, it is very a key aspect in small scale as well as in large scale. And the cost efficiency. So while comparing to others, it is a very less cost effective also. So these are the various benefits and advantages.
Okay, coming to the characteristics of embedded systems, like irrigation systems, like it's a dedicated system doing the prescribed or the dedicated functions. Like it will make the real-time processing. It's a sensor-based monitoring. Like the sensors and actuators process the data at real time, and at instant the signal will be passed and the measures will be taken. Like this system is low power consumption and it is fully reliable for long time operation.
So thus, by integrating the microcontroller, the sensors and the other output devices, we can design an efficient smart irrigation system with efficient power consumption, labor cost and the automation process where the human intervention is less. So thank you all.
Thank you.